Okay, let's take a look at a couple of exponential model questions and see if we can review how to do these kinds of problems. I've got the functions sitting right here for the exponential models. In the first problem we have a disease being spread in an exponential way. On day 6 there's 800, on day 7 there's 960. We need to find the function for the situation and find out how many people will be affected on day 30. So the key thing about these exponential models is there's a multiplying process going on. From day 6 to day 7 we multiply by something to get there. So we need to find the multiplier. We do that by dividing the newer value, 960, by the old value, 800. That turns out to be 1.2. If we go to our calculator over here, we can type in 960 divided by 800 and get the answer. Let's pull this over, you can see 1.2. That's the multiplier. So I know the function has to be y equals a, whatever that is, times 1.2 to the x power. Our next step is to find a. A is the starting value. It's where we started off from. And we'll find this by substituting numbers in. We have a number for y in the problem, a number for x that go together. We'll pick the one for day 6. We found 800 for y and the 6 for x. To solve this, we'll do the division. Divide both sides by the 1.2 to the 6th power. Excuse me, I didn't type in the 6 there. There's 6. So divide 800 by 1.2 to the 6th power. So let's pull the calculator over and we'll do that. 800 divided by 1.2 to the 6th power. Didn't get the power key there. There we go. So 267.91. This is the population, so we'll round that to the nearest whole person. A is 268. This means our model is y is equal to 268 times 1.2 to the x power. This is our exponential model. To do the second part of the question, how many will be affected on day 30, we substitute in the 30 for the x value right here. We'll go over to our calculator and type that in. 268 times 1.2 to the 30th power. We get 63,617. So that's a lot of people that get infected, because that's what happens with a disease. So we found the multiplier, substituted in, filled in a pair of numbers for x and y, solved for a. That gives the function, and now we can calculate anything we need for that situation. We'll do another one here where there's a little different thing going on. We have an endangered species that's declining 8% per year. This relates to the multiplier. The multiplier is what's left on the 100%. So we'll take this 8% away. That gives us 92%, which is 0.92. That's the multiplier. So we know the function starts off with, in this case, 9,400 animals, the current population. The multiplier is 0.92 to the x power. That's the general function for this situation. We're given what we need here, 1,000 animals. So we need y to be equal to 1,000. We can't just calculate this. We need to find when it's going to happen. That's a clue to use intersect. So y y1 will be 9400 times 0.92 to the x power. y2 will be 1000. So let's go to the calculator here. Y equals here. Fill in 9400 times 0.92 to the x power. So there's y1, y2 is 1000. We need to graph and find the intersection. The graph will not show very much right now because my window doesn't show the values needed. Notice we have 1000 maximum for the function we're looking for, and the 9400 it starts off with. We need to change the window. So hit your window key. Right here is our window. 50 is okay for x. Let's change the y max to be 10,000 to account for the starting value. Now hit graph. Here's the population of the animal over time. You see it gets very low. And here comes the 1000 that we're looking for, right there. We need the intersection right here. Calculator has a built-in program, intersect, on the calculate menu. Second trace, it gets to calculate we number 5 right here. Once you select that, hit enter 3 times. The intersection is reported as 26.87 years. We'll call it 26.9 years. Okay, hope that was helpful. If you have questions, let me know.